All right, this is lesson 17, practice problems. To summarize what we learned in lesson 5.17, we figured out that when you change the height of a 3D shape by a scale factor, its volume changes by the same scale factor. So it's basically telling you that, say for example, you have a cylinder and it has a height of 3. When you double that height, the volume will also be doubled. So whatever you multiply your height by, you will also multiply the volume by that same number. Okay, so let's get started. Problem number 1. A cylinder has a volume of 48 pi cubic centimeter and height h. Complete this table for volume of cylinders with the same radius but different heights. Okay, so this is the key here. Since the cylinders will have the same radius, it's only the height that's changing. That means we can apply this idea that we learned in lesson 5.17. Okay, so whatever you multiply the height by, you're going to do the same thing with the volume. So let's take a look. For the second row, the height got multiplied by 2. So you will do the same thing for the volume. You will multiply 48 pi by 2. And that will be 96 pi. For the third row, your height got multiplied by 5. So you will do the same thing for the volume. You will multiply the volume by 5. And 48 pi times 5, that is 240 pi. Same thing for the next row. Your height, you divide it by 2. So you will do the same thing for the volume. You will divide the volume by 2. And that will be 24 pi. For the last one, you divided the height by 5. So you will do the same thing for the volume. 48 pi divided by 5. You can leave it like this or you can simplify it. If you plug this into your calculator, you will get 9.6 pi. Okay, so the whole idea of this, problem number 1, is that when you have a cylinder with a fixed radius, meaning you're not changing the radius, you're only changing the height. You're multiplying the height by some number. To figure out the volume of another cylinder with the same radius but different height, all you have to do is to multiply the volume by the same number that you multiplied height by. Okay, so same scale factor for both the height and the volume. Okay, number 2. For number 2, you are given a cylinder. So cylinder and a radius of 3 centimeter and a height of 5 centimeter. So let's sketch that cylinder over here. So cylinder, you're going to draw an oval and another oval down here. Your radius will be from the center to any point on the circle, and that radius is 3, and the height is 5. So the volume of a cylinder, we can figure that out by using the formula V equals the area of the circular base, which is pi r squared times the height. And then let's plug in what we know. So pi, the radius is 3, so we will square that, times the height of 5. When you simplify this, 3 squared, that's 9, times 5. 9 times 5 is 45 times pi. So the volume is 45 pi cubic centimeter. Okay, next. What is the volume of the cylinder when its height is tripled? So the height is tripled, meaning you're multiplying the height by 3. Remember, based on what we learned from lesson 5.17, if you multiply the height by some scale factor, you will just do the same thing with the volume. That will be the new volume. So your height got multiplied by 3, so you did 3h. So you will do the same thing for the volume. You will also multiply the volume by 3. So the volume is 45 pi, so you're going to do 3 times 45 pi. So the volume of this cylinder now, when the height is tripled, would be 45 times 3, that is 135 pi. So that will be the volume of the cylinder when the height is tripled. That means when the height is 15. Okay, the next one. What is the volume of the cylinder when its height is halved? So halved means you will divide the height by 2. So remember, going back to what we learned earlier, whatever you multiply the height by, you will do the same thing with the volume. So height, this one you divide it by 2. So the volume will also be divided by 2. And our volume is 45 pi divided by 2. You can leave your answer like this, or you can plug it in. You can divide this, and this is 22.5 pi. That will be the volume of your cylinder. All right, so let's see. Okay, problem number 3. So a graduated cylinder, so you're given a cylinder that is 24 centimeters tall, can hold 1 liter of water. What is the radius of the cylinder? What is the height of the 500 ml mark? The 250 ml mark? Recall that 1 liter is equal to 1,000 milliliters. So you actually have 3 questions here. So first, you have to figure out the radius. Second, you have to figure out the height when the volume is 500 milliliters. And another one, you have to figure out the height when the volume is only 250 milliliters. So let's do this one at a time. So for part A, so A, the radius, that's what you're trying to figure out. The height is 24. The volume is, this is 1 liter, but we want to use the milliliters one. So 1 liter is equal to 1,000 milliliters. So the volume is 1,000 milliliters. Okay, so this is a cylinder. So the formula for the volume of a cylinder is V equals pi r squared, the area of the base, times the height. Again, I cannot stress this enough, but get started by writing down the formula. I know you can do it in your head, but sometimes that can be confusing. So write down the formula first. So bring down pi. The radius is, I don't know, that's what we're trying to find. So I'm just going to leave it as r squared. The height is 24. The volume is 1,000. So now we have to solve for r. That means we want r to be by itself. So if you look on the right side, you have to get rid of 24 pi. Right? So I'm going to do that. So I'm going to do divide both sides by 24 pi. 24 pi. So now I'm going to have r squared. This is gone. The pi is gone. I'm going to have r squared is equal to, when I plug this into my calculator, I'm going to do I'm going to simplify this first. This is 1,000 divided by 24 times 3.14 That is 75.36. So I'm going to continue over here. So now I'm going to have r squared is equal to, I'm going to divide that, 1000 divided by 75.36, and you will get approximately 13.27. So again, if you remember, this is r squared. We're only looking for the value of r, so we have to undo squaring. And we undo squaring by taking the square root. So we take the square root of both sides. So when you plug this into your calculator, the square root of 13.27 is approximately 3.6. So the radius is 3.6 centimeters. Okay? Now for part. All right. So question B, the next one. So for B, they're telling you that the volume now is 500 ml and the height is what they're asking for. So do I have to solve for the height by using the formula? No, you don't have to, because we know the relationship between the height and the volume. That whatever scale factor I used for the height, that will be the same scale factor as the volume. So let's take a look. What happened to the volume? It used to be 1000, but now it's only 500. So what did they do? They divided the volume by 2. So that means you will do the same thing for the height. You will also divide the height by 2. So the height originally is 24. So you have 2 divided by 2. So the new height now, when the volume is 500 ml, would be 12 centimeters. Okay, you don't have to solve using the volume formula because you know the relationship between the height and the volume. Okay, C. The volume now is 250 milliliters. So the volume is 250 milliliters. They want to know the height. Again, you don't have to use the formula for the volume to solve for the height. All you have to do is to check what's the scale factor. What scale factor was used on the volume. So this used to be 1000. Now it's only 250. So they divided the volume by 4. So that means you will do the same thing with the height. The height will also be divided by 4. So the height is 24 divided by 4. The height of this cylinder with a volume of 250 ml is 24 divided by 4 is 6. So 6 centimeters. All right. So again, we use the whole idea that we learned in lesson 5.17. Okay, problem number 4. An ice cream shop offers ice cream cones. So we have 2 ice cream cones. The waffle cone, so we have the waffle cone, holds 12 ounces and is 5 inches tall. So let me sketch that. So this is the waffle cone. Waffle. So this is 5 inches tall. And the volume of this is 12 ounces. Now the other cone is the sugar cone. So let me see the sugar cone. It says the sugar cone. Let me write it here. Sugar cone. The sugar cone holds 12 ounces. So that means the sugar cone also has a volume of 12 ounces. and is 8 inches tall. Oh, this one is a little bit taller than the other one. 8 inches tall. Which cone has a larger radius? Okay. This one, they're telling you that they have the same volume, but they have different heights. So without solving, we don't really have to solve for the radius for this, because they're not asking for the radius. They're just asking which cone has a larger radius. So let's just compare these two. Since they have the same volume, but different heights, this one has a smaller height. So for this to have the same volume as the sugar cone, we have to have a larger radius for waffle cone, correct? So the answer for this would be the waffle cone. The waffle cone has a larger radius. Because for them to have the same volume, and this one is shorter than this has to have a wider mouth, right? So they will have the same volume. Okay, the next one. Okay, problem number 5. A 6-ounce paper cup, 6-ounce paper cup is shaped like a cone with a diameter of 4 inches. So let me sketch that. I have a cone, so it's a cone. Diameter is 4, so that means the radius is 2. And this can hold, that means the volume of this is 6 ounces. How many ounces of water with a plastic cylindrical cup? So you have another container, but this one is in the shape of a cylinder. So let me sketch that. Oops. My cylinder is a little bit off. With a diameter of 4 inches. So the diameter is the same as the cone. So the diameter is the same as the cone. So the radius of this is also 2. So let's see. How many ounces of water will a plastic cylindrical cup with a diameter of 4 inches hold if it is the same height? So it's the same height as the paper cup. So say this is H. This is also H. So what will be the volume of the cylinder? That's what they're asking you. So the volume of this is what we're looking for. So recall what we know about a cone and a cylinder with the same radius and same height. Remember, we watched a video that if you have a cone and a cylinder with the same height, it will take 3 cones to fill up the cylinder. So we have 3 cones. 1, 2, 3. That's equal to 1 cylinder. So for us to figure out the volume of the cylinder, all we have to do is to multiply this volume by 3. So the volume of the cylinder will be 3 times 6. So the cylinder can hold 18 ounces of water. Okay, problem number 6. Lynn's smartphone was fully charged when she started school at 8 a.m. At 9:20 a.m., it was 90% charged. And at noon, it was 72% charged. So the question is, when do you think her battery will die? So first, we have to figure out how long it will take her to use up the 100%. And we will use the information given in the problem to figure that out. So let's see, from 8 a.m. till 9:20 a.m. she used up how many percent? So it's down to 90. That means she used up 10%, right? And how many minutes had lapsed? Well, from 8 a.m. to 9:20 a.m., that's going to be 60 minutes plus 20. So that's going to be 80 minutes. And then from 9:20 a.m. till noon, so that's 12, it's down to 72%. So from 90, it went down to 72%, which means she used up 18%. And how many minutes had lapsed between 9:20 and 12? That will be 160 minutes. So approximately here, how many minutes per 1%? So we'll do 80 divided by 10. So that's 8 minutes per 1%. So let's see over here. So that's 160 minutes per 18%. That's approximately 8.9 minutes per 1%. So we can approximate this that she's using up 8 minutes per 1%. So she's using up 8 minutes per 1%. So for 100%, that means we'll multiply that by 100. So she can use her phone for 8 times 100, 800 minutes. So now we know that she can use the phone for 800 minutes. All we have to do is to add 800 minutes to 8 a.m. 800 minutes is 13 hours and 20 minutes. So if you add 13 hours and 20 minutes to 8 a.m., that will be 8 a.m. So plus 13 hours and 20 minutes, that will be 9:20 p.m. So at 9:20 p.m., that's when her battery will die. All right, the last one is battery life a function of time? Yes, it is a function of time because the life of the battery depends on how much time she spent on the phone. If yes, is it a linear function? Explain your reasoning. No, it is not linear. It's not linear. How do we know that? Remember, when it's linear, the scale factor must be the same for both. So take a look over here. If you double the number of minutes, the percent used must also be doubled. But this one, it didn't get quite doubled. It's a little less than doubled, right? So 80 minutes, 160 minutes, that got doubled. This one, nope. So this is not linear. It's very close to linear, but not quite. Okay, so we're going to say, no, it is not linear. If the function is linear, it would lose exactly twice as much in 160 minutes as it did in 80 minutes. All right, so that's our homework for tonight. So do your homework and make sure you turn it in on time. All right, thank you very much. I will see you in class.